Aloha, Richard Halverson here. This is ITS128, and today is March 11th, and we're going to be doing a video. We're going to start chapter 6 today on functions, and I think it's like video number 11 we're going to do today. So let me share my screen. And let's check to make sure. Let's see. So to check to make sure, I go to my, and I have to do this because I'm an old forgetful man. And so I go to my YouTube playlist, which I just did earlier, but I'm showing you again. And it's a good idea to, you can just go here. You don't need to go to Laulima, because when I upload a new video, I set right on the first screen, I say what playlist it belongs to. And we have done video 11. I remember, now I remember, because we spent 4 videos on chapter 5. So that's why that is. And so I've attached video 11 to last week, the last chapter. And so today we're going to start video 12, and do section 6 point. Let's see how far we get in functions. All right, so open up Zybooks. And this is 128. By the way, just so you may notice here, I use Zybooks for all of my KCC classes. I also use it for this Manoa class that I teach, and we will be using I hope all of you go to 148. There's no reason why every one of you cannot move on to 148. We'll get you through this 128 if you're having any issues with the stuff. And it's the same thing, and we're just going to continue on the chapters. And one pretty neat thing, since you won't be taking 148 until next semester, is that all my 148 videos that I'm making this semester will be available for you. So anyway, the topics in 148 are a little bit more computer sciencey, and we get into analyzing which algorithms. Like, we'll look at 2 or 3 different sort program algorithms, and we'll analyze which ones are better under what circumstances. So anyway, we're in 128, and we're going to start chapter 6 today. Functions. I wonder what they mean by new content. I think it's new, just this here. Oh yeah, unit tests. Oh yeah, that's pretty important. Okay, so we've been using functions all along. Anytime you have a word with parentheses, and you put arguments in there, and it executes, and a number appears in its place in that place in the expression, that's a function. Also, those are called prefix notation functions, but also there's infix notation functions, which is add, subtract, multiply. Those are functions also, but you use those functions differently in a program, in an expression. So, but what functions are really good for is when you're going to make some code that you're going to reuse. If you're only going to use that code once in your program, then you don't need to put it in a function. But if you're going to use it more than once, then it's a good idea to put it in a function, because then you write that function, you get it to work, and then that's something you can rely on working, and use it in other cases. So here's an example where let's say you have a function and by the way, this is a function which converts a temperature Celsius to Fahrenheit, centigrade to Fahrenheit. And so we have some temperatures here, which we have some Fahrenheit temperatures here, and we're going to convert them to Celsius temperatures. And the equation is subtract 32 from the Fahrenheit temperature to get it to 0, and then multiply it by this factor, and then voila, you have the Celsius number. And so in this example, the person's doing it 3 times. Oh, but look, lo and behold, he makes a mistake this time. And so that's, the idea is that if you create a function f2c, and it looks like this, and f is the parameter, I'm going to make it a little bigger. F is the argument to the function, and what it does is it takes the argument, does its thing with it, and then the result, it returns that result. And so in the expression, that result is replaces that. So in other words, right here, for C1, we use F1, and once the calculation takes place, then the answer appears in this place, which gets stored into C1. Same with C2 and C3. The only thing that changes is the argument. And this way, if this is correct, then we know that all 3 of these are correct, which is different than in this case here, where the person made a mistake the 3rd time. They typed in the equation. Now let's see what this looks like. So we got 3 programs. Oops, made a mistake. So cluttered repeat code. Oops, there's an error in the 3rd calculation. Oh, it's cluttered and it's repeated. Yes. So we make a function here, and now this is simpler. So now when right, expression, let me just keep going here. Okay, even when you're not, let's see, how's this working? You have X, Y, Z here. I didn't look through this before okay, so it's repeated, so there's an error. So here it's called 3 times. It's simpler. Now the impact is even greater when the operation has multiple statements. Here are 3 statements, but commonly tens of statements. Program is much simpler. Okay. All right, I see the point. The point is, expression 1, expression 2, expression 3, expression 4, expression X, Y, Z, P, Q. Even without repeated operations, calling predefined functions keeps the program simple and intuitive. Okay, I think the point here is that, this, in this example, this may only be done once. You got a bunch of code that calculates something, and it's in the big long program, and you got a chunk of code right here that calculates something, and it's logically fits that you could separate that out as a function. You might use it again in some other program, and later on we'll show you how you can write your Python programs. So if you got some methods in there, some functions that you defined in there, and you would like to use those in another program and not the rest of the main program, you do some things, and then your old program is, the methods of your old program are, become available. They're saying here that even if you don't have this repeated calculation thing, it's still a good idea to use functions because it keeps the main program simple and intuitive. And it just makes it makes the program more readable, and it's also how you design the program. You start thinking big. Okay, you start by saying, okay, I have a bunch of numbers here that I'm reading in Fahrenheit, and there's 5 of them, and then I gotta convert them to Celsius before I can use them in my other calculations. And right then and there, you think, oh, I need a function which converts Fahrenheit to Celsius, and then you just would write this, and then you would write it this way, and that's how you would design it by this top-down approach that we learn in programming. All right, so so here's some questions to help you to make sure that you understand what I just said. Okay, so a function definition consists of the new function's name and a block of statements. There's this def word here. Did we talk? No, we don't. We haven't seen that yet, have we? And also, as we know, Python comes with these built-in functions. We've already been using them. Okay, but they're defined someplace else. Okay. We use def to define our own. So here's an example of figuring out the area of a pizza. Printing a pizza area from its diameter, I presume, radius from, well, no, this is okay. So yes, from its diameter. So you have a pizza and you measure the diameter of the pizza and you want to know what the area is. So you can define a function called print pizza area, and it you have to have pi. This is the equations for it, and then here where it's printed out, and then you've defined this in your program, but it's just a definition. Okay, you haven't asked it to do it yet, or you haven't asked anybody to do anything yet. You've only defined things. Here, the actual first statement of the program, this program's 2 statements. One, a def statement, and the print statement. The def statement happens to be, you can think of it as a compound statement. It's actually a function definition, and so it's got all this other stuff inside to return. Oh, and this function does not return anything. You'll notice. You just call it, and it does its thing, and then that's it. So we can run this, I guess, if we want to. So it's not until the first statement that actually does anything. This animation worked a little bit differently than I explained, but really what this was showing was execution. Okay. We're talking about execution. This is the first thing that's executed that actually does anything. Here we're just defining stuff. It's just reading it in and having it sit there waiting for somebody to ask it to execute. And so this is the first thing that executes, and that's what invokes the function. And then we see these all executing, and the last thing that happens is the thing is printed. So and then it's done. All right, so given the following program and this function defined above, this is the following program, how many function calls are there? Well, there's 2 of them. And how many function definitions are there? There's just 1 of them, because it's just this one. There's just 1 of them. It's just this. Is that right? How many output statements would execute in total? How many? Okay, we're talking about this. Still talking about this program. How many Output statements would execute in total. Output statements. I guess they mean this. Print statements. 2. How many print statements exist in the program code? 1. It's just 1 in the definition. All right. What are we supposed to do here? Participation activity. Well, anyway, this is a definition. This just prints out say cheese. This actually executes this, and then this prints out after this executes. So you can click on that and watch that. Print pattern prints 5 characters. Call print pattern twice to print 10 characters. Okay, so that does how do you call print pattern print pattern? How about for I in range 2? Oh, look, it worked. All right, basic function call. Define print shape to print the shape below. This is the output. Oh, I'm supposed to write a definition here. Def print shape. And so I can just do print and I want to do this 3 times, I guess. See if that works. Yeah, it worked. Okay, but really the simpleton way would be to do this like this. I'm just being fancy and being stupid here. This is really what they're looking for. Print it 3 times. See. All right, does it twice. Okay, parameters. Okay, so parameters are, you know, like in the Fahrenheit to Celsius example, the parameter would be the actual degrees, the integer, I mean, the floating point number of degrees that you put inside the parentheses. And parameter is a function input defined in a function. Argument is the value provided to a function's parameter during function call. So the argument is what it is outside calling it, and the parameter is what it is inside. Okay, so this is a parameter and this is an argument, as is this. So function B, parameters definition. I wonder if this would be a good time to click on present here. Okay, function with multiple parameters. Okay, so this one's got 2 parameters, and so, you know, order matters, order counts. So it looks like the first argument would be the diameter, and the second one's the height. So this is diameter, and this is height of the pizza. That'd be the width of the pizza. So this would be like thin crust, I don't know, normal crust or whatever. Okay. So yeah, this is just going to call 3 times, and each time it's going to take a different, you know, diameter of pizza, and it's going to make all the calculations and print it out. It's going to print out pizza diameter first, and then pizza height, and pizza volume. So pizza diameter, and then it prints an X, and then it prints the height, and then it prints these words, and then it prints the cubic inches, and then it prints these words. I mean the volume, that's the volume, and the height. All right, so that's that. All right, what's this? Type the program's output. Let's just start this and see what happens. Okay, type the program's output. Okay, so a variable called, okay, so there's a definition up here, but I don't have to look at it. I actually don't have to look at it until I actually come across this thing, because that's that. So ignore this for now. Let's see, first statement, age to print, it's 23. Okay, so that's 23, print age, and so this is 23 in there. Oh, now I have to go up here, and oh, this is 23. And then I'm going to type, I am 23. And that's it. Okay, what's next? Okay, here, there's a number, there's a price and a tax amount, and those two are added together, and that equals 31. So when this is called, this is going to be 31. So that means it's going to print out 31 right here. Just a second. All right, so you can do the rest of these. Okay, basic function call, challenge activity. Complete the function definition to output the hours given minutes. Okay, so this is the minutes, and it wants you to output this. Well, let's see, how many minutes are there in an hour? I think there's 60. So if I take minutes and divide it by hours, or take minutes and divide it by 60, I'll get hours. So I'm going to put here original. I'm only printing. This thing only prints. I don't pass back anything. Okay. I'm going to say hours equals orig minutes divided by 60, because those are the number of minutes in an hour. And oh, then I'm going to print that. Print. Let's see, I'll do that fancy. I'm just going to print it. HRS. I think that's all I have to do. Okay, and this thing reads in what somebody. This thing reads it in, converts it to a floating point number because it reads in as a string, as you know. And that's going to be put in the variable their minutes. So now let's say the guy typed in 210.0. Let's say that's what was typed in. This is going to be the characters 210.0, and then this is going to convert it into 210 at even. And then so minutes is going to equal 210. That's a floating point number. And then that 210 is passed into this function. So now I got to go look at the function, and here's the function. And so that's going to come in as, you have to make sure this is the same as that, because they could trick you. And so that 210 is there, and this takes 210, divides it by 60, and that's going to be whatever 210 divided by 60 is. I guess it's 3.5, and then this prints out 3.5. All right, function call with parameters, converting measurements. So we're going to convert feet. What is this? Converting hours to minutes, or minutes to hours. This is converting Okay, well, it's feet and inches, and you're supposed to convert it to, wait, inches. Oh, and prints the total number of inches. Okay, so you take the feet. Well, this is, well, that's coming up. Sample up. Okay, so we're supposed to create a function. Okay, I'm going to call it def print total inches. It's going to take two parameters, num feet. Let's put the F there, FET, comma, and num inches. Those are the two parameters. And it's going to take total inches equals num feet times 12, because there's 12 inches in a foot. Oh, what is this? This was yesterday, 2 days ago. So just so you can see this the way you would write it as an equation. See this. I mean, you know this. You know that it's number of feet times 12 plus number of inches. But what you might not be handy with is the actually what's going on with the algebra. So you know how it should turn out, and I'm going to show you, remind you how it's expressed. We have in this case we have 5. Oh, so 5 5 feet times 12 inches per foot, okay, plus plus 8 inches equals, and what it equals is 68, right? Equals 68 inches. Now, you look here and you see there's a feet on top and a feet on the bottom, okay, FT. Well, you can cross that out and you cross that out, and now we're not even talking about feet anymore. We're able to get rid of the feet because of this, the way this equation is. Okay, 12 inches per foot. Well, this just equals, when you think about it, this just equals 1. 12 inches equals 1 foot. So it's whatever this is, and it's over the same thing. It's 1. So you can multiply anything by 1. Okay, so we're taking 5 feet. We're taking the 5 feet. We're multiplying it by 1. And the only reason we're doing that is to cancel out the terms. And what we end up with is inches. Okay, so now this whole thing is inches. And by the way, it's 5 times 12, which is 60. And then we're adding some more inches. And so the result is going to be inches. So that's the algebra of expressing something that you already know. But I just want to kind of reinforce that, because that's kind of how you got to think these. Sometime you know, you're going to be given like something like this, and it's going to be more complicated than this, and you got to step by step figure out and see, do I divide by that number or do I multiply by that number? Well, if you just write this over this and that over that and start canceling stuff out, you can see, oh no, the feet are on the top. Feet are on the top in both of these. Well, that must mean I have to divide, because then I can cancel out the feet. So anyway, oops. So it's a number of feet times 12 plus num inches. Okay, so that's the expression. And then you can, I think we're just printing it out, right? Print total inches, colon, quote, space, total inches. And I think that's all we got to do. Leave. Yeah, good. All right, returning values from function. Now we're actually passing stuff back. So in this case, we are returning a calculation. Okay, this is actually really, we're seeing two things at once here. We're seeing the parameter coming in and it's being multiplied by itself. So that's an expression that gets calculated into one number, and then we're going to return that one number. And what this does is this means replace this in the original expression with the calculated result. And so what's the original expression? Well, it's this one. This one was where it was called. This one. So this is where this was in the original expression when it was called. And so this is going to be replaced with whatever the calculation is. So that means this is going to be replaced with that calculation. I'm just talking about this, not that, this thing. And so that gets stored in there. And so now that has a value, and it's this value. And so when this is executed, this is printed out, followed by a space, followed by this value, and that's why this prints out like that. So that's what this is going to show you. 7 goes to there, and then it comes down here, and I get 7 times 7 equals 49, and then it goes to here, and then 49 gets replaced with this swing, and yeah. So, all right, none is a special keyword that indicates no value. Yeah, it is that. We seen that here? I don't get what am I supposed to? We gotta make this smaller. Yeah, okay, so okay, does it finish? Okay, that's where it's called. And that gets executed, and that gets executed, and it gets returned down to there, and then it prints. It doesn't have anything to do with none. Complete a program by writing and calling a function that converts a temperature from Celsius to Fahrenheit. I want to know why they put that none right there. How do I exit presentation view? A function can only return one item, not 2 or more items. Okay, you're right, got it. So a function can only return one item. Now, of course, you can make a list. You know, if you want to pass back more than one item, you know, you can make a list and then pass back the list. That's one item. And then if the person that, or if the program that called is going to know that it was a list that comes back, and then can separate it out, or a tuple. No function, a function with no return statement, or a return statement with no following expression, returns a value none. None is a special keyword that indicates no value. Right. Okay, so that's why they put that's why they explained none there. Yeah, a function always returns a value. Like this, well, no. This one, when a function is just sitting out there, just all by itself, not on the right side of an expression, or not on the right side of an assignment statement, but right there all by itself, then all functions sort of return something, but a function that isn't intended to return anything just returns none most of the time. But in other languages, they actually do return functions, but if it's just sitting there all by itself, it may do something and return a value, but the programmer's not going to do anything with that value. So it does not have to be on the right side of an assignment statement, or it doesn't have to be within an expression. It can just be sitting there all by itself. It returns a value. The programmer does not care about the value that it returns. It just cares about doing the function, which could be like print, and then so it just gets discarded. It doesn't print out anywhere or anything. It just kind of disappears. All right, so here's temperature conversion. So what's going on here? Complete the program by writing Celsius to Fahrenheit. Use this expression. So I'm gonna take this and I'm gonna copy it, and I'm gonna put that right in here. I'm gonna paste it, and I'm gonna centigrade to Celsius. Centigrade to Fahrenheit. Okay, so this is what I'm gonna return. I think I want to put C here. That's this, and oh, this can't be an X. It's got to be an asterisk. I think that's all I got to do, and I'm going to return F, the capital F, that thing. Or I could do it how they did it, and they combined everything together. I think I'll do that. Take this and put that here. And I don't need this at all. How's that? Okay, call the conversion function. Temp F equals C to F of temp C. This comes in, goes in there, gets converted to this using this function, and I want to print it out now. Okay, that's it. $50 to $122. Okay. See, this is what's confusing. By the way, Zybooks is working on an improvement to this, where it will actually look interactive, just like if I were to run it in my, in my prompt here. I can take. Anyway, I could show this to you. Maybe I could use this later. I don't need to show it to you now. Let's keep moving. Okay, hierarchical function calls. A function statements may include function calls known as hierarchical calls or nested function calls. A function statements can include function call. Well, yes, known as okay. So basically, what they're saying is functions can call functions inside. So here we have we're talking about pizza calories. So this is the main program. We actually don't need to even look at any, assuming it's all correct. We don't even need to look at any of this stuff up here. We can skip past the defs, and then we go straight to the first statement that actually causes anything to happen. That's this. So it prints out this, and oh, here's where it calls the first function. So that function is this function. Okay, so I got to look at this now, and it takes in a parameter, and then it defines calories per square inch. And then it calls another function. Well, where's that? Oh, now I got to go and look. Now I got to go and look at this. And it takes in the pizza diameter. And see, this just, this doesn't have any context of pizza. There's nothing about here, nothing about this function that has anything to do with pizza. All this function does is take as an input a diameter and calculate and return in its place the area by this calculation. Okay, it takes pi circle. The formula is pi times r times r. R is the radius, and the diameter is twice the radius. So you got to divide the diameter by 2 to get the radius, and then that's that. Multiply it by itself by pi. And even though this is about, even though we're talking about pizza pies down here, and this is pi, that has nothing to do with it. They're spelled differently. Okay, so it's pi, PIE. Anyway, so this thing returns the area there, and then it takes the area and multiplies it by the total calories per square inch. So this needs to return inches. It doesn't matter. This doesn't have any a notion of inches or feet or anything, because this comes in as inches, and that's inches, and it returns inches, and it returns inches, and you multiply calories per inch. Yeah, inches. We got inches times calories per inch, and these cross out, and you end up with just calories. So the result of inches times calories per inch, the result of that is calories, and so that prints calories. Anyway, so that's that. Looks like it works. It looks like it would work. Enter the output of the return value. These are always kind of fun. So change value 2, and what does it do? It adds 1 to it. So it's going to be 3. Okay, you can do more of those. What is this one? Function call in expression. So here, well, we already know about this. Max sum is the greater of 2 numbers that are passed to it, plus the greater. Assign max sum the greater of this plus the greater of this. Use just one statement. Call max fun. Call. All right, what's going on here? Okay, so we have num A, num B, num Y, num Z, and we're supposed to we want to know. First, we find the maximum of these two. Then we find the maximum of these two. Then we find the maximum of the maximums. Okay? No, that's not right. Oh, sum. Oh, wait a second. Max sum. Oh, we find the maximum and the maximum, and then we add them together. Okay, that's what we do. So this is the, okay, so this, okay. Okay, so find max. Now, transaction. Okay, so this thing finds a maximum. And what I want to do is max sum is the find max of find max. No. Oh, no. It's not that. I'm thinking it's more complicated than it is. So this is num A and num B. So that's going to be the max of num A and num B. And we're just supposed to sum the maxes. So then I need to do find max of num Y and num Z. And that's max sum, and that's going to go in there. So that's what, okay. See, so this just finds the maximum. And I'm supposed to find the maximum of this and add to that the maximum of this. Use just one statement. Oh yeah, this is one statement, I guess. All right, is this the answer? Is this the right answer? Yeah, good. Okay, function definition. Volume of a pyramid. Okay, this thing is the volume of a pyramid is base area times height times 1/3. Is that what it is? A pyramid. I didn't know that. Volume of a pyramid. Volume of a pyramid. Volume of a pyramid. It's base length times base width times pyramid height divided by 3. That's the volume of a pyramid. What do you know? Well, I'm gonna copy this formula right here. I'm gonna be sneaky. Will this help me? No, it's not gonna help me. It's better if I copy this formula. Volume equals base times height. Okay, copy this. My solution goes here. Okay, so it's gonna be def pyramid volume parentheses something. And then I'm going to put in here this, and I'm also going to put in this. Except for I got to put it up above here because I got to first figure out the base area, and then I got to use this. I got to use that here. Okay, so we have length, width, and height divided by 1/3. So what comes in here? Length, width, height. Okay, I'm going to just call it that. And no, I'm going to go ahead and call it base length and base width and pyramid height. No, I'm just going to call it. I'm going to call it these names down here. Okay, so let me put that here and then height. Oops, that shouldn't be there. Okay, so base. I'll call this base area. That's okay. It's got to be the same case. So I'm going to make this the same case. And this is base length and times base width. And this has got to be an asterisk. And so does this. And I think that's oh, this has got to be an asterisk also. And so this is okay. It's going to multiply this by multiply it by 1, and then divide it by 3. And that's okay. That'll work. I'm just going to leave that how it is. Of course, I actually don't need the ×1, but I'm going to leave it there because I'm showing you how simple it is just to copy from this down to there. And the answer is this. And I guess that's what I return. It's got to come back here. So I'm just going to return all that. And you got to make sure the cases of everything are the same. Can't be any spaces there. And let's see if this works. Yeah, it works. Ooh, guess that's okay. Well, yeah, sure. Okay. What's next? Dynamic typing. Polymorphic functions. Okay, so this has to do with the behavior of being able to add together different types of a concept called, okay, dynamic typing means that the Python will determine the typing based on the objects that it is passed. Okay, so let me just exit presentation view here. So here we're seeing that this function, a function that looks like this, can be used for, you know, it uses, okay, what this is doing is it's converting an infix expressed function with the prefix with infix. So you know, it's taking this function, which the way you use the plus operator is you put it in between the two operands, whereas the way you use this also adds, but you put the two operands after the word add and you put it in parentheses and you express it in this function notation. So all this thing does is it's converting from this notation to this notation. Yeah, that's fine. And as with this, what they're saying is this is a polymorphic function because this is gonna be concatenation when it's passed in strings, and it's going to be, you know, integers when it's passed in integers. It would be floating point numbers when it's passed in floating point numbers. So let's see this is just going to show that. Okay, and then this. See, that returns concatenated strings. So, and not all programming languages are that way. This Python uses dynamic typing, whereas in languages like C or C++ or C++ or Java or C# uses static typing, which means the programmer defines what it is, and that's what it is. You can't change it. Okay, can't change your mind. Okay, you have to define a new variable if you want something different. And other languages are dynamic typing too. PHP is. I think you would consider JavaScript also dynamic typing. Yes. Okay, polymorphism refers to how an operation depends on the involved object types. Is that true? Yeah. A programmer can pass only string arguments to a user-defined function. No, that's yes. Okay, anyway, you can finish these. Reasons for defining functions. Improving readability. That's a good reason. Programs have become hard. Really? Does it say improving readability anywhere? Well, anyway, yeah, this improving readability. Decomposing a program into functions can greatly aid program readability. And so here's an example. Without user-defined functions, the main program is harder to understand. this is exactly the same as this, but we have these functions up here. Because here they're all kind of mixed in. It's all kind of mixed into the program. Here we've separated out, logically in our minds, we've separated this out, and it makes it easier to understand what's going on. Modular program development is another reason. It's how you develop it. If you're doing something, if you're writing a program that does whatever this does, you probably would write it. First, you'd write this stuff, and then you'd go down and you'd write this stuff. Okay, that's how most of the time, that's good programming practice, to stepwise refinement. And so, why not code the same way you're designing? That as opposed to this, you go, okay, I'm going to read something in, and then I'm going to compute the feet. Okay, what do I need for the feet? Well, I got to know feet per step. Okay, well, I got to put that up here. Whereas in this case, you're going to say, all right, I'm going to compute steps to feet and print it out. Then I'm going to compute steps to calories. Then I'm going to print it out. And then you can deal with this and this as step 2. It avoids redundant code. We saw an example of that with the pizza diameter, where you're doing exactly the same set of operations more than once, and the only thing different is some identifiable parameter, and then you write a function to replace redundant code. All right, it's let me just finish this. Write a function so that the main program below can be replaced by simpler code. The simpler code that calls this function instead. So you want to call this function instead. So let's make that function def. Just copy this whole thing here. Copy, paste. And I got to take this here. I'm going to take these two statements, and I'm going to put them here. From here, better put a colon there. This thing. So I got miles per hour, which is this. I've got minutes traveled, which is this. And so I have everything here to calculate that, which is used here. And I have this, and I have this, and I have this. And so I guess I return this or something. Yeah, this is what I would return. Miles traveled. So I guess it looks something like this. Yeah, okay. All right, so we are done here. Let me just tell you, okay, so next we're gonna go function stubs, and that's just another sort of a way of designing where, you actually create something that's called a function, that with the name of the function, and then you just put that there and put a pass, and that makes it a valid function. Function's got to have at least one statement, and all that does is just returns with nothing, and it's like a placeholder. And then you can go on and debug your program, and when the time comes to actually test this, then you can that's when you come in and you replace the pass with actual code. And so this has to do with more of methodology for creating functions and or creating programs with functions. And so here we're covering functions that have branches and loops. And then here functions are actually objects, which means you can pass them, and talk about common errors, and then scope's important too. So anyway, we'll continue this next week. And in the meantime, if you'd like to start looking at the labs, and as you know, as I mentioned before, all the labs are in the labs were all covered last week or last semester. So if you want to work ahead, you can go look at the last semester's videos. However, it looks like there's a new one here, so I will definitely be covering this in this chapter. So anyway, okay. So are there any questions? Yes.
I think I'm doing okay. Yeah.
Okay. All right.
Okay. Thank
Good.
you.
Thank you guys for this is a very large class for me. You know, there's 2 people who showed up, but thanks for coming. It's always nice to have an audience, and then we'll see you next week.
Okay. All right. See you later.